All right, other quadrilaterals. So the diagonals of a trapezoid also divides the trapezoid into two triangles. The difference is, however, it's not two congruent triangles. All right, because your side lengths opposite of your trapezoid are not congruent, unlike a parallelogram. So you don't create two congruent triangles. You actually can create two separate triangles. Now what you will notice, however, is that the height of the two triangles is the same, but the bases are not. So you basically have 1/2 for your first triangle. You have 1/2 your base of your first triangle times the height of your first triangle, which is just the height. And then you're going to add to it the second triangle, which is 1/2 the base of the second triangle times the height. Now, what they do to actually create this formula is they pull out your common terms here. Your common terms here are the 1/2. So if I were to take this out, I could take out a 1/2 and a height, 1/2 and a height. So I can take that out in front and then have my bases added together. And you'll see that's what the formula is here for a trapezoid. The formula for a trapezoid is 1/2 times your height, and then in parentheses you add your two bases, base 1 plus base 2. So 1/2 times your height, base 1 plus base 2. And they get it from the fact that it creates two triangles. Even though they're not congruent, you can still use, it's based off of your triangle formula. All right, so 1/2 your height, and then in parentheses, base 1 plus base 2. Base 1 plus base 2. That is your trapezoid. All right, so let's look at calculating a trapezoid. Calculating a trapezoid. Look at example 1. Example 1. Find the area of each side of a popcorn box if the sides are 6 inches tall. Its top edges are 4.25 inches, and its bottom edges are 3.25 inches. Your height is going to be your perpendicular distance between your two bases. All right, so these are my bases. My height is the perpendicular distance, and I'm just going to plug it in. 1/2 times my height, and then base 1 plus base 2. All right. And you should get, well, actually, it's exact. They didn't have to round to 22.5 because it was in inches. Remember the double dash there is inches. That is square inches. 22.5 square inches. That is a trapezoid. Now, a kite also creates two triangles. It's a little bit different, however, with these two triangles because you have basically half of one of your diameters. That is your height of each triangle. And then your base is going to be another diagonal. And so you actually use your diagonals here, even though it's still based off of your triangle formula. The formula for a kite is going to be 1/2 your diagonal 1 times your diagonal 2. All right, so let's look at how we used it here. They've given us this kite. Now, in this particular case, they didn't give me the diagonal length, so pay attention to what they've done. They've given me 115 millimeters here, 115 millimeters here. And then they've given me 13 centimeters here and 30 centimeters here. All right. So the first thing you have to worry about is making sure that you have them all in the same unit. You can't have centimeters and millimeters. You would not have inches and feet. Okay. And so we have to convert from one to the other. They converted from millimeters to centimeters. All right. So if we take just over to the side, if I want to take 115 and I want to convert it from millimeters to centimeters, then I'm going to say, well, how many millimeters is in a centimeters? There are 10 millimeters in every 1 centimeter. So when you're doing conversions, if what you're trying to get rid of is in the top, to convert it, it needs to be in the bottom because you actually want those to cancel. So if I have 115 divided by 10, which is what this works out to be, I'm going to get 11.5 centimeters. It just moves the decimal place over 1 to go from millimeters to centimeters, okay? So 115 millimeters equals 11.5 centimeters, okay? So I would rewrite this as 11.5 centimeters, but that's only half of my diagonal. So my formula is 1/2 diagonal 1. If this is half of my diagonal, I have to double it, so times 2. So that's going to be 23. 23 centimeters all the way across here, all the way across. All right, everybody see that? So that's 23 all the way across there. And then what's my other diagonal? What do I need to do there? It's 13 and 30, so what's my other diagonal going to be? This is bad, huh? All right, this is going to be 43 centimeters, right? 13 and 30. And then you just plug it in. 1/2 times 23 times 43, and you are going to get a decimal because of that 1/2, 494.5. We converted this to centimeters, so my units are square centimeters there. If I had done it in millimeters, it would actually be a lot more. I would have to change this to 130 millimeters and 300 millimeters, so it would have been larger numbers. But either conversion is fine as long as they're both in the same before you actually plug it in. They have to be in the same units. Rhombus is actually exactly the same. It's 1/2 diagonal 1, diagonal 2. It's based off the same formula. They show you what it's based off of. It's based off of that height, that perpendicular height. In this case, they actually want you to solve for the height because there's 2 ways you can do a rhombus. A rhombus is a parallelogram, which is just base times height, right? And then you have a rhombus if you use the diagonals. In this case, I cannot do base times height because I do not have my height. So when you're given a rhombus, you have 2 ways to solve. You can go back to your parallelogram formula, which is base times height, if you have those. Or if you have the diagonals, you can do 1/2 diagonal 1 times diagonal 2. So there's 2 ways to solve for a rhombus, okay? They actually want us to find the height. We have been given the base, but that's not enough. So first we have to calculate the area. Then we're going to use the area to find the height. All right? So for this rhombus, we're going to find the area first using our diagonals. 1/2. This diagonal, they only gave me the 4. It's actually double that, right? So it's going to be 8. This diagonal, they only gave me the 3, but I need both pieces. So that's going to be 6. So my area here is going to be 24 square meters. All right? Area is 24. All right? They want me to solve for the height. If I know the height and now I know the base, I can use my other formula for a rhombus, base times height. Base times height should equal the area of a rhombus because it is simply a parallelogram. So then I'm going to plug in what I know, solve for what I don't know. I know my base is 5. I do not know my height, but I do not know my area is 24. All right. So if I divide, I get 24 fifths or 4.8. 4.8 meters, or in the book, I think they wrote it as a mixed number as well. All right. So there are 2 ways to solve for a rhombus. You can use your 1/2 diameter 1 times diameter 2, or you can use your parallelogram, base times height. It just depends on what you have and what you don't have there. So you can put these on the coordinate plane. The ones that they gave you in this particular section are rather simple because they actually put them directly on perfect perpendicular with the axis, okay? If they had this turned, like shifted, you would have to actually use your distance formula, all right? If you look at this quadrilateral, you can tell this is a rhombus. There's a, yes, I mean, it's, if you know what you're looking for, you can tell it's a rhombus, all right? So, if you were to just go across here for this diagonal, or if you were to go down with this diagonal here, you should be able to see that, first of all, they're perpendicular based off of the actual graph itself. And then you have 1, 2, 3, 4, and 1, 2, 3, 4. So they bisect each other. 1, 2, 3, 1, 2, 3. So you can see the diagonals bisect each other and they're perpendicular, which tells you it's a rhombus. All right. So it tells you that this is a rhombus. In order to then find this, you need to know your diagonals. And so you need to know the length of them. And so, like if this were shifted, you would have to use the distance formula. But what you'll notice is that this has a x value of 1 and an x value of 1. So you literally just need to know the perpendicular distance between them. So to go from 5 to -3, how far do I have to go? You just subtract. So 5 minus -3, those are going to be 8 units apart. So that tells me that this diagonal is going to be 8 units. For the other one, you'll notice that your y values don't change, so you just have to worry about your x values. And it's absolute value because it's distance, so -2 minus 4, absolute value of -6, this guy's going to be 6. So you can look at the coordinate plane and figure out what your diagonal lengths are. If they were not directly on a perpendicular or horizontal line, you would have to use the distance formula to solve for your length. But because they're on a perpendicular and horizontal line, you can just use your one x value or your y value. So then I have the area of a rhombus. That's 1/2 one diagonal times the other. So that's going to give me 24 square units, whatever the units may be for this one. All right, so when you're given it on a coordinate plane, you just have to know what type of figure you have and then use the formula accordingly. So go ahead and try number 8.